Tonight's video is going to focus on our third learning target for this unit. It's about momentum, and it relates to our Newton's second law as well as our unit on motion. On your gold unit organizer in slot 10, you need to write in momentum, notes, and GP, which stands for guided practice, and this will be worth no score. The note sheet that's going to go with this video looks like this. It's labeled as Momentum Notes in GP, and it'll be page 10 in your binder. In momentum, we study impulse momentum, and the first question we need to answer is, what is momentum? I think a lot of you use this in your everyday life. For example, if you're going down a hill on your bike, you need to gain momentum in order to go up the next hill. My husband frequently complains when I ask him to stop at the grocery store that he loses all momentum on his bike riding home because the grocery store is at the bottom of a hill right before he has to go up another hill to come back to the house. But the reason he complains so much is that because momentum is mass and motion. And typically momentum is conserved. So again, the reason he complains is because he loses momentum, so he has to work harder to get up the next hill. And the two factors that affect momentum are mass and velocity. The formula for momentum is P is equal to m times v. Now eventually you're going to have to solve for different parts, but for right now we're going to focus on the straight multiplication problem. P stands for momentum. Well, that's strange. Why wouldn't they choose m? Well, m already stands for mass, as well as meter, milli, and a few other things. So they picked a different letter for momentum. And v stands for velocity. The unit for momentum is going to be kilogram times meters per second. This is the actual unit. It's called a derived unit. We don't shorten it to anything. This is what it is. And how you say it is kilogram meters per second. If you say kilogram times meters per second, that's okay too. The unit for mass will always be the kilogram, while the unit for velocity will always be meters per second. Now, how can we have the most momentum possible? Well, if momentum is equal to mass times velocity, we would want to have a lot of mass going really fast. So we would have a high mass and a high velocity. Now we can change an object's momentum, and in order to do that we would either have to change the mass or the velocity. But it's more practical to change the velocity of an object to change its momentum. It's pretty hard to change the mass of an object. Now we're changing the velocity, which means we're changing the motion. And in order to change the motion of an object, we're going to have to apply a force. And that force is going to come through impulse. So the second question we're going to ask ourselves is, what is impulse? Impulse is a change in momentum. And it's measured by applying the force applied to an object by the time it's applied for. So mathematically, it would look like F for force times T for time. Now, how can we connect force and momentum? It's our third question we're going to answer in our notes today. Impulse momentum can be related as follows. Force times time, which is impulse, is equal to mass times velocity, which is momentum. So we use impulse to change the momentum of an object. Now let's get force by itself. So in order to do that, we have to divide each side by t, or time. Then t goes away on that left side, so force is equal to mass times velocity over time. Now I want you to notice something. We have v over t, or velocity over time. This is equal to acceleration. So let's sub in acceleration for v over t. Force is equal to mass times acceleration. And we learned in Newton's second law, which is what this is, that if we change the force applied to an object, we are going to change its motion. It's the same exact thing with impulse momentum. If we apply a force over time, we're going to change the momentum of an object. And if we want to change the momentum of an object, it's easier to change the velocity. So we're going to apply a force to change the motion in order to change the momentum of an object. Everything is connected in physics. Some applications we're going to focus on in terms of impulse momentum theorem are the two that follow. If we extend the time, we make it longer for the object to decrease its speed to 0, which means we're going to increase the time it takes to slow down, then the force is going to decrease. For example, you're drinking a glass of water in a real glass cup, and you drop it on your carpeted floor. The glass is going to be less likely to break because of the cushioning used by the carpet. So our first example is you're dropping a glass on a carpeted floor. So the carpet equals more time, which is going to equal less force. The second example we can think about are football players. Did you ever think about why they wear a helmet? Well, the helmet gives them more cushioning or more time to absorb the impact from tackles and headbutts. So a helmet for football is the same idea. It extends the time for the object's speed to slow down, so the force goes down as well. But say we decrease the time it takes for the object to slow down, then the force would increase. Say you're drinking that same glass of water, but now you're outside, like on the sidewalk. So if you drop your glass on concrete, it'll be more likely to shatter because there's less cushioning, which is equal to less time, which is going to be equal to more force applied to the glass. So it'll be more likely just to shatter all over the place. Now, because we're in physics, of course there's some math. I'm going to do 3 out of these 5 problems with you, and you're going to be required to do the last 2 on your own. You are going to do 3 and 5 on your own, and I'm going to do 1, 2, and 4 with you. Our first problem says, what is the momentum of a 110 kilogram running back crossing the touchdown line at 9.2 meters per second? I'm looking for momentum, which is P. I'm given 110 kilograms, which is a mass. I'm given 9.2 meters per second, which is a velocity. P is equal to m times v, which I got from the beginning of the note sheet. So my mass is 110 kilograms times 9.2 meters per second, and that's going to be equal to 1,012 kilogram meter per second. Our second problem says, what is the momentum of a 0.045 kilogram bullet leaving the barrel of a gun at 890 meters per second? Again, I'm looking for momentum, which is P. I'm given 0.045 kilograms, which is a mass. I'm given 890 meters per second, which is a velocity. P is equal to m times v, which is going to be equal to 0.045 kilograms times 980 meters per second. When I multiply these two numbers together, I'm going to get 40.05 kilogram meters per second. You're going to do 3 on your own. Now 4 says you are dropping an egg off a balcony, which you'll actually do next week. If the egg, which has a mass of 0.02 kilograms, falls for 4 seconds at a speed of 9.8 meters per second, how much force will be applied to the egg when it hits the ground? Alright, there's a lot of things going on in this problem. I'm given mass, which is 0.02 kilograms. I'm given 4 seconds, which is a time. I'm given 9.8 meters per second, which is a speed. And it says how much force will be applied. So I'm looking for force. Now if I go back into my note sheet, it looks like I can solve for force given mass, velocity, and time. So my equation I'm going to use is this one right here. So force is equal to m times v over t. My mass is 0.02 kilograms. My speed is 9.8 meters per second divided by 4 seconds. So first I'm going to multiply 0.02 by 9.8, and then I'm going to divide that number by 4, and I should get 0.049. Now, the hardest part here is the unit. I'm solving for force, so I should immediately think that my unit for force is the Newton. You're going to follow the same pattern for question number 5. So make sure you do questions 3 and 5 on your own before you come to class next.